The author Arthur C. Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." AI is so advanced that people have dedicated entire careers to understanding it. I can help you get acquainted with machine learning in general and how it's different from everything that came before it, and how different flavors of machine learning can solve different kinds of problems you will certainly encounter in the future. Machine learning is a new type of programming, a way of telling the computer what you want it to do. And it looks a little like magic. To understand how machine learning works today, it's helpful to understand the evolution of programming. We started with BASIC and COBOL and Fortran, and now we have JavaScript and C++. These are strict instructions for the computer to execute exactly. Next came mathematical models, simple ones like Excel spreadsheets. Change the values to play what-if games, and even change the formulas between the values, which are just short programs linking one cell to another. After that, we have handcrafted statistical models with lots of assumptions built into a mathematical replica that reflects the real world well enough to make predictions. You start with a year's worth of data, 12 months, and you take the first 9 months and create a model that perfectly describes the first 9 months mathematically. Then you run a prediction to see what the model predicts would happen in the last 3 months. You compare that to the actual 3 months. If it doesn't look like the actual 3 months, you tweak the model until it does. And when it does, you can use it to predict the future. That's not foolproof, but it beats flipping a coin. Now, machine learning, different. It looks at a pile of data and builds a model all by itself, based on the data. It looks for patterns and derives rules about the data from the data and uses that to answer questions or make predictions. The learning in machine learning comes from the fact that the computer can change its mind. When new data shows up, it reassesses, looks for new patterns, and updates its own mathematical model of the world. Given lots of data and lots of compute power, we now have the machine do the model creation and tweaking at speed and at scale. If you want to write a program to do accounting, you can talk to a bunch of accountants, get them to tell you the specific steps, and then just write the instructions, follow the bouncing ball, paint by numbers. But ask those accountants to hand you a pen and ask them how they knew it was a pen. They just recognize it. They don't have a list of pen characteristics in mind, and they don't run through a checklist. But once they learn the difference between a pen and a pencil back in grade school, they can recognize all sorts of different pens. Give machine learning enough examples, and it doesn't write a program to check the boxes. It builds a model of what a pen should look like, and then comes up with a statistical likelihood that this is a pen and not a toothbrush. The important thing to remember is that these different tools, programming, spreadsheets, predictive analytics, and machine learning, all have their advantages depending on the type of problem to be solved. So knowing when to use which tool is just as important as knowing how to use the tool. You don't want to dig a deep hole with a fork, and you don't want to eat dinner with a shovel. You should know that there are 3 types of machine learning that can solve different kinds of problems: supervised, unsupervised, and reinforcement learning. Supervised is where you know the answer. You give the machine lots and lots of examples and ask it a question like, is this a picture of a dog or a cat? Who out there looks like my best customers? Is there anything in the sky that looks like an asteroid or little green men from Mars? That's supervised learning. You already know the answer. Do what I tell you. Unsupervised learning is where you ask the machine something that you don't know. Tell me something new. Find a pattern. Show me a correlation, something that I wouldn't know to look for. Unsupervised is, tell me something I didn't know. Reinforcement learning is different. You give the machine a task and a goal, and it makes changes that improve the outcome. You want more email opens? The machine can crank out a bunch of subject lines and see which ones get more opens. Then create and test subject lines that are more like the ones that got more opens, and it learns from its own actions. Knowing which tool to solve which kind of problem is a critical capability these days, and once you get it, you'll be able to take full advantage of this magical software that we call machine learning.